And thanks for joining. The recording has started. Let me start sharing my screen, and then we can take it off from there. Right. So let me share it to desktop. Just let me know once it's available or visible to the rest of the folks. We can take it from there. Navid, are you able to see the screen?
Yeah, I can see it. I can see it.
Okay.
Great. Thanks, Angie. All right, so welcome everyone. Happy Fridays. So welcome to Power Lunch. Hopefully you'll have a good lunch after this powerful session. Today's topic is Azure Virtual Network Peering. It's a core networking concept. Many times people don't kind of focus much on that stuff. They just seem that everything might work, but I think this is one of the area which is kind of most critical when you start your Azure journey, because if you lay the foundation correctly, you are kind of bound to be successful out there without kind of redoing your networks, redeploying stuff, or kind of moving stuff around down the line. And this gives you a peace of mind to both your networking and security teams. And we'll see how it does all of that for you. Before that, a quick introduction. My name is Paresh Sharda. I'm a TSP for Azure Infrastructure. I'm an MCSC. I've been pretty much given all the certifications you could see out there. But in short, I am an IoT fanatic, and I love tinkering stuff around at my home. I use Azure IoT Hub for a lot of my personal projects also, and I just feel this is too awesome. So if you want to talk anything on IoT or IoT Hub, feel free to ping me. I can talk for the whole day. With that, quick view of the agenda. We'll go through very quick service updates in the past 1 or 2 weeks. What has came out new in Azure? It is the highlights one, not all of them, and then we'll deep dive into the topic itself. You could subscribe to Azure updates by going through this link, which would be available to you. And before I go there, so let me just go ahead and view to the Azure update. I wanted to cover quite a few of them, but my favorite one was, I don't know whether it was covered during last session or not, but it was the certification for the Azure M series VMs for SAP HANA. So we knew this was going to come quite a while, but there were few of the delays because of some storage upgrades. But finally, we have 4 M series VMs which are available in quite a few number of regions across the globe, which are certified to run your HANA workloads, which basically means you can go up to 3.8 terabytes of your HANA workloads onto Azure on-demand VMs like M series. And if you have anything more beyond that, you always have HANA large instance option as well. With that, wanted to spend some time on another area around virtual network, which was released generally available recently, which was basically using the virtual network service endpoint for Azure Cosmos TV. Now, if you are not aware what virtual network service endpoints are, it's basically gives you a mechanism to tie in some of those platform services like Azure Storage, Azure SQL, and now Azure Cosmos DB to a specific virtual network. So you restrict access to those platform services only through that specific virtual network. You could always kind of protect them through authorization and authentication, but they still used to have a public endpoint. But by doing this, you actually restrict even the public endpoint for those platform services. A few other things which came out in GA, one was the Azure Database Migration Services. So this is kind of a single service which would be available to you to migrate your on-premise databases into Azure. Right now, the 2 areas where it has been made GA is specifically on the SQL Server to Azure SQL database, as well as to Azure SQL managed instances. And then last one was during the build, which we mentioned, right, regarding the public preview of Azure blockchain workbench, which is basically we have been doing a lot of work around blockchain within Azure. The ecosystem is growing up really fast, but the major challenges out there was kind of a lot of time when anybody wanted to get started with blockchain development. There was a lot of kind of work required to do the scaffolding, because blockchain ledger by itself will not be helpful or will not be useful that much unless and until it gets integrated with either your other systems, ERPs, CRM, and all other stuff. So with this, you have kind of integration to Workbench. You will have the ability to integrate with many of the Azure services like Azure AD, Key Vault, Logic Apps, Flows, so that you developer can focus more on developing their stuff rather than kind of figuring out the entire scaffolding for the specific application. All right. With that, let me quickly jump to the topic of the day, Azure Virtual Network Peering, and I would like to start off with this screen. I think you might have seen this quite a few of time and might kind of get bored with it, but I wanted to start out there because this actually lays the foundation of why virtual network peering makes really sense. We are growing really widely across the globe, and as more and more regions are coming on board, there's always this tendency to kind of deploy the workloads where your end users are. And when you do that kind of thing, then the next question obviously comes in: how do I connect virtual networks, or how do I connect both of these workloads across it? So that's the reason I wanted to start off with. These are various regions, around 40 regions right now across the globe, and more coming. With that, just wanted to highlight the distinction between geos and regions, because when we started global VNet peering, we got this confusion that, okay, does it mean it is within the same geo I can connect, or within the same region I can connect, and all that kind of stuff. So to clarify that distinction, Azure, what an Azure geo means is kind of a geo which is laid down by the geopolitical boundaries or the country boundaries. So probably North America could be one of the geopolitical boundary, right? So we consider that as one of the geo rather than a region. While a region is kind of a set of data centers which are defined by a bandwidth and a latency envelope. So basically, two regions would be probably hundreds of miles apart, with around 2 millisecond latency when the data goes from one region to another region using our own dark fiber. So from an end customer perspective, you are not going to see different data centers within a region. The most granular part from a kind of a deployment perspective would be, if I had to say, would be, okay, which region you want to deploy your stuff into. All right. And pretty much each of these regions are completely fault tolerant, completely independent, because they are 100 miles apart, and probably even safe from major natural disasters. Now, when it comes to Azure and networking, there are two core areas you want to focus on. One is how do you connect to Azure, and how do you connect within Azure. So to connect to Azure, I think we can cover this on a later on point of time, but basically you have four options. You directly connect over the internet, you go through point-to-site connectivity, which is kind of a more of a developer or remote employee kind of a scenario. You connect through site-to-site VPN connectivity, which is more enterprise grade, if I had to put it up, where based on the gateway SKUs, you can get up to 1.3 Gbps of speed throughput with site-to-site. Then express route is private connection, so both of those VPNs still use internet and encrypted tunnels to communicate, while express route is through your provider or through an internet exchange, a private connectivity into Azure. But when it comes to connectivity within Azure, you have two options. Before VNet peering was available, the only option was like VNet to VNet via gateways, which was basically kind of a site-to-site VPN, where you spin out two gateways in two different VNets, and then basically connect using VPN. The traffic was encrypted, obviously, because of the VPN, so there was this extra work which was required, and then the bandwidth was limited to the gateway SKU which you had selected. So which basically means like you couldn't even go above 1.3 Gbps. even with that kind of connectivity. And that's where the VNet peering came in. VNet peering basically allows you to connect two virtual networks, either within a region or across a region. So if I had to define Azure virtual network peering, it is basically virtual network peering enables you to seamlessly connect two Azure virtual networks. Once peered, those virtual network appears as one for connectivity purposes. We have two flavors there. One is local VNet peering, which is also many times called just VNet peering, which basically means you are connecting the VNets within the same region. So let's say US South Central. It doesn't matter whether it is in one of the zone or one of the data center, one VNet got deployed there while the other VNet got deployed somewhere else. But as far as if it is in the same region, you will be able to connect using local VNet peering. The other option is global VNet peering, in this case where you have two different regions, US South Central, US North Central, US East, US West, and you have VNets deployed there. There are multiple reasons why people do that, both due to certain restrictions which are on the Azure side and maybe due to some other criteria. But if you have your Azure deployments which are spread across multiple regions, then you can use global VNet peering, which also was made GA just recently. Now the question is, why would you use virtual network peering? Why not continue to use either the gateway approach or maybe just keep it separate altogether? But to highlight some of the core benefits of virtual network peering, when you peer virtual networks, it works at the fabric level of Azure. We basically go ahead and make sure that the traffic between those VNet peering VNets is completely private through the Azure backbone. You will get a low latency, high bandwidth connection between resources in different virtual networks. So for example, if you are using, let's say, local VNet peering, when you peer two virtual networks, from a latency and bandwidth perspective, the communication between those two virtual networks would be as good as you will get when you are communicating within the same virtual network. It's all then dependent on the VM you have chosen, the SKUs, and the net capacity of that virtual machine. But pretty much it's same. It goes to the backbone. And then the other option would be we do have few customers who might still be on the older deployment model, and they might not have completely migrated to ARM model, the resource manager model. And if you still want to connect those two resources or those two virtual networks, then VNet peering would be one of the options for doing that, beyond those gateways and VPN gateways you have to do. And the last one is primarily when you do this VNet peering, there's practically no downtime. It's more of a configuration settings. You set it up, and once you're done, basically you can go ahead and start using that. The traffic can start flowing across those peering itself. With that, I wanted to focus on why this VNet peering entirely came into existence and why it makes sense to use it beyond those benefits which I mentioned earlier. Traditionally in IT, if you see, there's always kind of a hub and spoke kind of architecture. And in Azure and public clouds in general, this architecture makes much more sense. And I work with lots of customers who want to implement something like this. Before VNet peering came in, the only way you could do this was either using those VPN gateways. And when you set up those VNet to VNet VPN gateways, there's always this cost associated with those gateways running all 24/7 across each of the gateways. That was one of the reasons. The second is, from an IT and security perspective, when a security team wanted to kind of set up some of those monitoring appliances, or the networking wanted to set up some of their networking or network packet filtering and packet inspection appliances, when they were connected directly through express route, they had to kind of either move the entire traffic back to on-premise and pass it through those appliances, or create those virtual appliances in each of those virtual networks, and then basically have additional cost and the management overhead of managing multiple instances of those virtual appliances. So that was another challenge out there. And many times where customers required more than 10 virtual networks and they only had one express route standard gateway, there's a limitation on express route gateways where you basically can only link 10 virtual networks to that gateway directly. So in this case, that cases, you either have to buy the premium add-on or basically go to a hub SKU, which again added additional cost. So all of those reasons lead to why you might want to use hub and spoke technology. So basically, first is the cost savings. Like the hub can have those centralized virtual appliances like those network NVAs, and then any of the shared infrastructure with like DNS, ADDS servers, ADFS servers, and WAN optimization servers, because that's the entry point for you to connect to your on-premise network. So there's obviously cost savings there, so that you don't have to deploy all of that again and again in all other virtual networks which come out. There's always subscription limits, and I'll show you that in a kind of a hub spoke model down the line. But basically, right now there's a subscription limit of a single VNet can only peer to up to 10 virtual networks, and maximum it can go up to 50. By default, it limits to 10, and then it goes to 50. But if you want to overcome that, probably you need hub and spoke kind of technology or topology. And then obviously the separation of concerns is basically where you have your hub virtual network or hub virtual core subscription, which is being managed by your IT ops, while your actual workloads, whether it is dev, test, or production, can work separately on each of the other virtual networks or subscriptions. So that's why hub and spoke makes sense, and that's the only reason why virtual networking actually adds advantage to this hub and spoke technology. I'll give you an example of what you could do, and then maybe we'll quickly switch to the portal to just show how it can be done. But here's an example of, let's say we have a hub virtual network. Sorry, I don't know. Click it, but okay. So here's an example of hub virtual network, where basically you have your VPN gateway which goes to on-premise, while you have a network virtual appliance which you want to monitor. What you could now do is you could set up a peering across two other virtual networks which are still not connected to on-premise, and basically peer them into hub virtual network. Additionally, what you could do is what we call service chaining, which basically means that using user-defined routes, you can configure the subnet, the virtual network A, to have the next hop as the network virtual appliances, which is in the hub virtual network, so that all the traffic from here goes to this NVA, and then this NVA can go ahead and inspect and verify, and then reroute the traffic based on the configuration which is in NVA. If it is destined to, let's say, on-premise, then it redirects it to VPN gateway. If it is destined back, it can go back somewhere. Similarly, in case of subnet B, what is happening here is there's another option where you could actually allow gateway transit. What that basically means is when the VMs within the subnet B wants to connect to on-premise, you could use this peering, and you can configure this peering to allow gateway transit. That way, this subnet B doesn't need to have its own gateway, which again obviously saves cost, and you could only use the same current VPN gateway to connect back to on-premise. So this is another use case of VNet peering beyond service chaining, and how you could save cost beyond that. When it comes to connectivity, let's say you have hub and two spokes. When you connect spoke 1 to hub and spoke 2 to hub, that by default doesn't mean spoke 1 and spoke 2 can connect by each other. You will have to kind of set up an additional VNet peering between spoke 1 and spoke 2 if you have to do, if you want the traffic to communicate between each of them. So that's where I mentioned, right, the service chaining helps, where basically you can also redirect both of the spokes to use UDR as the next hop to the NVA, and then NVA can then decide in which direction it can go. So you could actually kind of establish spoke connectivity using this kind of the service chaining mechanism also. And then obviously it also gives you the central control over the traffic and the monitoring capabilities across what's going on across in each of the networks. Another area where you could use VNet peering is basically on the limits. So as I mentioned, that there are few limits around number of peerings you could use, and that's where you could use kind of hub spoke technology or topology, where basically you can make multiple hubs and then connect each of the hub out there. Then you can use service chaining to either connect through each of the spokes or basically even restrict the spokes to talk to each other. Okay. Now, obviously, there are always things to consider whenever you want to do this kind of work. To start off, obviously, networking is networking, whether it is on-premise or on cloud or at home. So there cannot be an IP overlap across those networks. Otherwise, they won't be able to peer. That's pretty straightforward. The other thing is when you want to use peering, and because peering goes at the fabric level, which basically means the things needs to be trusted. There needs to be a high degree of trust, if I had to say that, across each of those networks. So if you want to peer two virtual networks, they need to be kind of part of the same Azure AD tenant, so that they can be peered at the fabric level. Otherwise, even if they are different subscription, that's fine, or different resource group, that's fine, or different location, that's fine, but they still need to be part of the same Azure AD tenant for the VNet peering to work. If that's not the case, then your option is only to use VPN gateways and peer those virtual networks. Now, when you are using global VNet peering, you have to think that you can peer to virtual networks, but you cannot peer across like public cloud and Gov cloud. So the Azure national clouds, you cannot peer virtual networks which are in those clouds. Obviously, you get the reason why you shouldn't be able to do that. You also cannot communicate with IP addresses of your internet and load balancers. So these are few of those gotchas you need to keep in mind when you are trying to connect global VNet peering. So basically, one resource in one region cannot use a load balancer of another region to kind of balance traffic to this region traffic. So that will not work out. Also, when you cannot use those remote gateways when you are doing global VNet peering. So let's say I had a gateway here in South Central which is connected to my on-premise, and I have a VNet in West region which also needs to connect to on-premise. Then I cannot use remote gateway transit basically, or remote gateways in that configuration if they are across different regions. Okay. The last, or maybe the next one is quite critical, is basically once a VNet peering has been done, you will not be able to add any additional address ranges or make any changes into the address space of the virtual networks which are peered. So if you have to make those changes, you will have to delete the peering first and then remove the address or recreate whatever you want and then recreate the peering. You just cannot disable the VNet virtual network traffic also. The peering itself has to be deleted in that case. And this is the last one, which is very critical if I have to put it up like that, because many times I do hear from customers saying that, okay, now if you are talking through your internal backbone, probably there shouldn't be any charge, but no, there is nominal charge when you are using VNet peering, both the local as well as the global VNet peering. So this is an example of South Central, which I took yesterday, but just go to the virtual network pricing page for the latest prices and which are specific to your region. Okay, so this has both. In this case, just keep in mind that there is an inbound and outbound data transfer rate also. It's not the typical bandwidth which you see in Azure where your inbound is free while outbound is being charged. In case of peering, it is charged on both sides. But if you compare this to, let's say, the previous option of like setting up VPN gateways on both ends, you will still find that this is much more economical and more faster and secure, obviously, because it's completely private to implement and easy to manage because you have one less component to manage, one less gateway to manage down the line. Okay. With that, let me quickly switch to page, and then maybe we can quickly show you how it is done, and then I think we have a few more minutes. I can show you a very quick demo if you want, or we can directly take up the questions. I see there are a few questions here.
Yeah, Paresh, I think there are a couple of questions, so let's go through questions. And I can paste the link to the VNet peering site in the IM window.
Oh yeah, yeah, I have included them in the deck as well. So if you want, we can. Okay, I can do that also. So okay, to start off with the questions,
yeah, please go ahead.
Is the load balancer limitation going to be resolved? Not right now, or not that I have an info which I can share with you right now. But I can take that back with the teams and see. That's correct. Okay, now can we connect AWS VNet for customers? You could always connect that using VPN devices, okay, but not using the VNet peering. You could set up VPN devices and connect to virtual networks across it, which would be your, and for that matter, it doesn't differ from an on-premise location to any other cloud location, right? So that wouldn't, that you, but cannot use the VNet peering capability to do that work, okay? Keep posting any more questions you have, and before I can switch quickly to the demo. So here's a simple example of how it works. Is basically here I have two VNets. One is in South Central while another is in West. And yes, problem with site to site is cost and limited bandwidth. But again,
actually, there is one more question, Paresh. It
okay.
asks about can we use OMS Network Performance Monitor for VNet peering, global or local?
So what kind of monitoring would you want out of the VNet peering? So basically, you could use the OMS network monitor to monitor each of the virtual network. If you are looking for those network watcher where you want to kind of use some of the packet and those kind of things, like packet inspection and those, that yes, you could use the network watcher there. But basically, there's nothing much to, if I have to put up watch, except for, let's say you want to figure out what your routes are, what your effective routes are. All of that can be still used with the existing toolset which is available in Azure. Okay. Gateway transit on roadmap for the, I guess, global main. Okay. Yeah, I don't have the timeline for that. This is an action item I can take. Maybe we can connect later on, but right now we don't have any timeline on. And guys, just remember the global VNet peering came out like few weeks back, maybe 3 weeks back. So I'm pretty much sure our PMs are listening, and you will see some good news down the line. But right now I don't have any timeline around it. Okay. While okay, we are getting more questions, I can just quickly go ahead and click on. So basically, you go to the VNet peering page. You go to your virtual network, click on peering, and then basically go ahead and click on add, and then that's where you can give a nice name to the peering, and then basically select the virtual network which is available to you. So in this case, I have the another one which is in West US 2, and then I can define whether what. So for example, I can use forward traffic. So this is another option which basically when you are using the service chaining capability and you're using NVAs, you will require this option to be selected. If you are using gateways or remote gateways, you will have to use the gateway transit and use remote gateways out there. It won't work right now because I don't have a gateway in either of my virtual networks. So it doesn't work there. But basically that's it. You give it a name, here, and that's it. Once it's done, I would be able to kind of communicate across those virtual networks. Great. With that, that's pretty much I wanted to highlight today. Any further questions, feel free to post it right now on the chat or connect to me or Naveed later on.
Yeah, please feel free to connect to us offline and we'll be happy to address. Otherwise, if there are no questions, then thank you, Paresh. It's an excellent session.
Thank you guys for spending some time on a beautiful Friday morning.
Yeah, I hope everyone has a wonderful weekend, and thank you, Paresh. See you next week.
See you guys. Bye-bye.